This video accompanies Learning IoT with Python and Raspberry Pi. In this video, you will learn how to identify the effect of some common programming mistakes, such as a misspelled variable or class name, using the wrong case, leaving off a delimiter, failing to define a variable before it's used, and forgetting a colon in a compound statement. We'll first consider several short scripts in order to illustrate the effect of a particular mistake. We'll then consider how to debug a script that has multiple syntax and semantic errors. We'll write a script that prints out the message oxygen levels normal, reads in the number of measurements, assigns 5 to the variable n, and adds the number of measurements to n if the number of measurements is greater than 10. We'll omit the opening parenthesis in the print function call that prints oxygen levels normal. When the script is run, a syntax error occurs, and information is provided that there were unbalanced parentheses, brackets, or braces. If the closing quotation mark is omitted in the print function call, the line is highlighted and a syntax error occurs when the script is run. Next, both parentheses are omitted from the first line. So essentially the first line is just the name of the print function followed by a string literal. And a syntax error occurs when the script is run. Next, we capitalize print. Because Python is a case-sensitive language, it doesn't recognize print with a capital P as a print function, and hence a name error occurs. Because a print function call is not part of a suite, nor is it a continued line, it must begin in the first column, hence spacing over 1 causes an indentation error. Suppose I was not assigned a value. When the if statement is executed, a name error occurs. Sometimes you have to look before the line where an error occurs in order to fix the mistake. Although we intended for the number of measurements I to be added to n if I is greater than 10, a type error occurs when the if statement is executed. We fail to convert the string returned by the input function call to either an int type or a float type. The source of the error occurs before the if statement is executed. When writing the if statement, we intended for the clause header to be followed by a suite. Because there is no colon, the augmented assignment statement for n can't be interpreted as the suite. Because the statement for n is not indented 4 spaces with respect to the clause header, it is not interpreted as part of the suite. This is why an indentation error was raised. Now we'll space over the augmented assignment statement, and the code will run as intended. After the if statement, we'll add a print function call that prints out the value of n, and we'll run this code twice. Once inputting 11, and next inputting -3. We'll next write a script that gets the pressure from the SenseHat emulator and then scrolls the pressure. If you have the actual SenseHat device, you may use that rather than the emulator. If you do use the SenseHat emulator, make sure you start it before you begin running the scripts. Because the SenseHat class is not built in, it must be imported. Since the SenseHat class was not imported, a name error occurs when an attempt is made to assign an instance of the class to the variable sense. Now we include the import statement. If you are using the actual SenseHat device, you should replace sense_emu with sense_hat. In order to instantiate the SenseHat class and assign it to the variable sense, SenseHat must be followed by parentheses. No error occurs on this line. However, when an attempt is made to call the getPressure method on sense, a type error occurs because no instance of the SenseHat class exists. Suppose you misspell the name of the method, leaving out one of the s's from showMessage. In that case, an attribute error will be raised. If you forget the name of a method of a class and an instance of the class has already been assigned to a variable, that is, an instance of the SenseHat class has been assigned to sense, you can type in the name of the variable, in this case sense, followed by a period and press the tab key. A menu of SenseHat attributes will be displayed. Suppose you misspell the name of the variable pressure, adding an extra E. There is no syntax error in the assignment statement in which the getPressure method is called and what's returned is converted to a string type. However, when pressure, with the correct English language spelling, is passed to the showMessage method, a name error occurs because pressure with the correct English language spelling has not been defined. When we remove an E from the pressure assignment statement, the script will run without error. Let's consider a Python script that is riddled with errors. Suppose that the specification for the script is to prompt the pizza parlor customer for the pizza topping, determine the extra cost for the topping, prompt the customer to enter how big a slice of pizza he or she wants, calculate the price of the pizza, and print it out. In particular, the script should print out "Welcome to Grizzly Mac's Pizza Parlor, home of the Arctic deep dish pizza," followed by the toppings 1 pepperoni, 2 sausage, and 3 cloudberry. The customer should be prompted to enter a topping. If the customer chooses pepperoni, then the extra charge will be $2. We haven't yet decided what the extra charge should be for sausage. The customer chooses cloudberry, then there will be no extra charge because reindeer devoured the remaining stock of cloudberries. The customer should be prompted to enter the size of the slice he or she wishes to purchase as a percentage. The total price of the pizza should be calculated and printed out. The name of the Python script is Pizza Pie. The first block of code prints out the welcome message as well as the 3 topping choices. Next, the pizza parlor customer is prompted to enter a pizza topping. An if-elif-else statement is used to determine the extra cost for the topping. The customer is prompted to enter slice size as a percentage, and the customer's response is converted to a float type and is assigned to the variable pizza. The price for the pizza slice with the topping is calculated by multiplying pizza by 0.35. The price of the whole pizza is $35, and the extra cost of the topping is the same regardless of the size of the slice. Finally, the price is printed out. Note that because of where some of the mistakes are located, nothing is highlighted. You may wish to pause the video here and make a note of all of the errors before we go through them one by one. There is nothing wrong with the first print function call, which goes over 2 lines. This is an example of implicit line joining. The Python interpreter searches for the closing parenthesis, which it finds on the second line. When Pizza Pie is run, a syntax error is raised, and Thani displays information in the Assistant tab about what specifically is the error. Because the script stops running, there is no information about errors that occur later in the script. We'll add the opening parenthesis to the print pepperoni function call. When we run Pizza Pie again, another syntax error occurs, and we're pointed to the elif clause header. Thani does hint that a colon is missing, which is indeed the source of the error. We'll add the colon. When the script is run again, an indentation error is raised because the Python interpreter expects the suite to follow the clause header. Although we haven't yet decided how to handle this choice, there must be a suite. Hence we'll assign the variable extra a value of 0 because this won't change the price of the pizza. Another way to handle this would have been to use a pass statement. If we used a pass statement instead of the extra assignment statement, another error would occur. Can you think of what this error would be? When we run Pizza Pie again, another indentation error is raised. We'll indent this print function with respect to the else clause header and run the script again. We intended to convert the response to the slice size question to a float type. No specific information is provided about what is causing the error, but information about where the error occurred is provided. A set of parentheses was left off. The string literal, enter the slice size as a percentage, must be passed as an argument to the input function. We'll run the script again after enclosing the string literal by parentheses. The final syntax error occurs in the final print function call. Once again, there is no specific information about what is causing the error. Arguments must be separated by commas. We'll fix this mistake and run the script again. We'll enter 1 for pepperoni. and 100 for the slice size. Notice that a name error occurs because extra has not been defined. At first glance, this doesn't make sense because the variable extra was assigned the value 2 if choice is equal to 1. Consider further that reindeer devoured the remaining cloudberries was printed out. There actually is another error. In the if-elif-else statement, choice is compared with the integers 1 and 2. However, choice is a string type, not an int type, and the string literal 1 is not the same as the int type 1, and the string literal 2 is not the same as the int type 2. Errors of this kind are much harder to track down than syntax errors, and even expert programmers make them. There are two ways this can be fixed. One is to convert the string type returned by the input function to an int type, and the other way is to compare choice to the string literal 1 and to the string literal 2. We'll choose the latter way. Also, we'll assign 0 to extra in the else suite. Now the code runs as intended. Again, we'll enter 1 for pepperoni and 100 for the slice size as a percentage. In order to make the output look nicer, we could have used a format function call or a format method call. We'll enter 2 for sausage and 50 for the slice size. Finally, we'll enter 3 for cloudberry and 67 for the slice size. And the answer is 2345. We'll cover the tools that can be used to track down semantic errors in another video. Learning IoT with Python and Raspberry Pi is available at Barnes & Noble.